Hello, everyone. How are you doing? First of all, I would like to thank you, the organizers, for this edition of Tech Week. In this presentation, we will talk about mutation test. But first, let me introduce myself. My name is Isaac, and I have a degree in computer science. I have been a software developer for a decade, and I specialize in using the .NET platform with C#. And I have been working at AvenueCode since March 2021. When I'm not working, I enjoy a few hobbies. I'm a big fan of sports, especially NBA and football. I'm a travel lover, so meet new places, know different people and cultures. So if you also enjoy this content, my wife and I have an Instagram page. It's called Time to Travel Blog, where we share some photos and tips about our travels. Please follow us. And I'm also enjoy a good beer, but my favorite absolutely is the IPA style. Okay, before we talk about mutation tests, let's think and discuss what software testing is. And the first thing I did when preparing this presentation was to quickly search for the definition of software testing, and I found this. Software testing is the investigation of software in order to provide information about its quality in relations to the context in which it must operate. It's a simple definition that gives us an idea of what testing is about. After that, I did a deeper search and found another more complete definition made by Martin Fowler, which says we should have a test suite that will catch almost all bugs in the software, so that when this suite passes, we can release that version of the software into production. But it also allows us to use refactory to improve our productivity and responsiveness in the next month. I really like this quote. And he's a reference in the world of software development and software testing. And testing not only prevents most bugs from happening, but it also provides a sense of security for a factory and enables to safely deliver new features into production. Okay, this leads to some question. Why do we test our applications? First, we can think about writing tests to have a better code. We can assume that if our code is difficult to test, it's probably because the code was poorly written. Therefore, once we have a good test suite, it will help to write maintain more readable and workable code. Another important point is to validate the business rules. We write tests to validate the points that the business team asks for us. New rules or changes to existing flows need to be made, and there is nothing better than writing tests to ensure that they are as requested. In addition, it ensures that we have security in the implementations of these rules. Safety to perform refactoring. Who has never needed to make a change to make the code faster, or because the flow is slow, or the code is not following the best practice, and we need to go there to a specific point in the code and change it. How are we going to ensure that our change didn't generate any collateral effects? The answer is simple. Test. Imagine make a big change to a specific point where there are no tests. We can be sure that we didn't affect any other part of the application. So if we have tests, if we have these scenarios with tests, we can go there and have the security to perform refactoring. Avoid manual testing. Writing tests help several areas. So if we can create a good test suite, we can reduce this time so that it can be focused on other scenarios and facilitate this work. So it's another benefit. And here is an interesting point. Do we write tests just to increase code coverage? It is very common for organizations to require a minimum value of test coverage before delivering any functionality, which I see is a good practice. However, it is not uncommon to see people thinking about writing tests with many quotes here, just to achieve this minimum value so that their activity is ready and leaves to the queue. Is reaching this coverage enough? And here we have the code coverage. It is very important. It is a number that makes sense to track and to understand how much of our application is covered by tests. And here we have an example of a small code snippet showing a method that checks if a person's age is in the risk range. Again, code coverage is important, but not 100% reliable. And why? Here we have examples of these tests for the methods where we validate if a person's age is 65 years old and he is in the risk range, and the result is true. And in another example, we validate if a person with 30 years old isn't in the risk range, and the result should be false. Everything looks good. However, people identify a strange behavior. People aged 70 years old are not being considered in the risk range. And we realized that despite having 100% code coverage, the behavior wasn't as expected. We have several types of tests, and we can start with the traditional ones, the famous testing parameter. First, we have unit tests, where we create validations for a single unit or method with external dependence being built with mocks. Next, we have integration tests, where we start integrations the components of the applications. For example, in the backend, we have a test that will make a request to a route, going through business validation, recording or retrieving information in the database, and finally validating if these components are working together. And at the top of the pyramid, there are the end-to-end tests, or the UI tests, where we've evaluated the behaviors of the entire system, from user input to output. And again, at the base of the pyramid, we have unit tests, where most tests will be, and also the cheapest to build. Cheap in terms of time and processing, which affects cost. And as we move up the pyramid, the tests become slower to execute and build due to the complexity of building an environment for them. And the cost also increase. But we have several other types of tests, and we can highlight some others. In a current scenario where we have microservices architecture, there are contract tests, which are a software testing technique that focus in the interactions between different services. And the next one is performance testing, which measure the ability of a system to handle increasing workloads and maintain it efficiently under peak conditions, and which can include many users accessing the system at the same time, or a large volume of data being processed in the short time. And last but not least, we have mutation testing. This is an important question to consider when thinking about tests. Do you think all of scenarios can really validate and ensure all behaviors? Here we have a quote from Mauricio Anishi, who has published several books about software development. Someone's specific focus in software testing. And he says, a strong test suite is one that reveals bugs to you when bugs happen. So the objective of testing is find issues as early as possible, preferably in the development environment, where it will be quicker and cheaper to fix them. And finally, we have reached mutant testing. Okay, mutation testing, it is a concept that has been around for a quite long time. It emerged in the 1970s, but until a few years ago, the focus was mostly entirely academic. However, nowadays there are several tools for most major programming languages. Okay, but what are mutation tests and how do they work? To answer these questions, we first need to understand two hypotheses on which the concept of mutation test is built. The first is competent programming hypothesis. And according to it, most faults introduced by an experienced programmer are due to small syntactical errors. And the second one is the couple effect hypothesis. And according to it, simple faults can cascade, generating new errors. Okay. These tests introducing mutants and mutations. And we have mutants, a small mutations that are introduced into the system's code, simulating defects that could occur in the real world. And these mutations can include, for example, the inversion of logical operators or swapping variable values. Mutation tests are based on when mutants survive, meaning that the test passed, which in this case is a bad thing. As a change was introduced, good quality tests should break. And also dead mutants. And when tests fail, indicating excellent quality in our tests. Okay, the mutation tests are based on mutation score. And that is a metric to evaluate the quality of mutation testing. It measures the percentage of mutants in the system's code that are detected by mutation testing. This mutation score is calculated by dividing the number of mutations by the total number of mutations introduced in the code. And the result is multiplied by 100 to get a percentage. For example, if there are 10 killed mutants of a total of 10 total mutants, the result will be 100%. And another example would be 7 killed mutants out of a total of 10, resulting in a score of 70%. Whether this score is good or bad depends the specific metric used, which we'll discuss shortly. Okay, nice. Here we have the Striker Mutator. It is an open source mutation testing tool designed to automate the process of mutation testing. It allows developers to identify gaps and also improve the quality of the tests. The Striker Mutator supports several programming languages, such as C# with .NET, JavaScript, and Scala. And here is the documentation of the tool in case anyone wants to read more about it. Okay, but the focus on these presentations will be on striker.net, and I will explain how it works and how to install and use it. It supports basically all current versions of .NET, including .NET Core and some versions of .NET Framework or full framework. It can be used via command line from installations to code generation. And something cool that we have in striker.net is the generations of visual reports, which shows which mutations were detected by the test and which mutations were not detected. And the report also includes a mutation score that shows the percentage of mutations. Here is the installations of striker.net. It can vary a bit depending on the environment, but we can install it globally with the command .NET to install -g .NET Striker, or only in the project inside the specific folder by removing the -g flag from the same command. Okay, now we have mutators, and the mutators are responsible for making changes to the original source code to generate mutants, and then testing them to verify if the tests are capable of detecting the mutations. There is several types of mutators, and each mutator is responsible for making a specific change to the original code. For example, change an arithmetic operator to another, negating a condition, or modify a constant. And here we have some examples, such as arithmetical, equality, logical, Boolean, or assignment. And a nice point to highlight is that when we have greater than sign, for example, Striker won't just change to less than sign. It can change to a greater than or equal sign, or equal or not equal sign. So the possibilities are very complete. And they help us to identify possible issues. And here is documentation for the mutators of that Striker.net supports. We have some considerations to deal with. Depending on the characteristics of our tests, executions may take several hours because Striker will perform the mutations on each test. So we may have tests where 4, 5, or even more mutators will be created. Considering that we'll have hundreds or thousands of tests, it can be time-consuming. One alternative is to schedule the test, for example, at the end of a week. This was an option we used on a project where I worked on. We followed this schedule strategy, and at the end of every Friday, a pipeline with mutation tests was executed for all microservices and monoliths. Okay, but will the whole project be changed? At first, the answer is yes. The default is to inform which test project will be changed and the test executions begin. However, we have some options to avoid this. The first one is used with Git. We can use this approach in a pull request, for example, by executing only for the new codes. Striker will identify the code difference, and reports will be generated considering only this new code snippet. It is possible to exclude files. We don't want to be executed in a particular file because it's some specific configurations like login or initialization, where this type of configuration is not needed. Exclusions of methods. We can configure a method where we don't want the code change, and the Striker will ignore and move it to the next. And mutators, I showed some examples of mutators, but if there is one that doesn't make sense to change, we can configure Striker to ignore that mutator. And we can configure everything through with JSON settings. And here's an example, which is basically the default file of Striker. We can configure how the report generations will be done and can progress or visualize it. We can set the required score for the test. For example, if we set a score of 80 or more, it means that the quality is very good. At least 60 or if something is low. And if the score isn't above 50, the test will fail. The concurrence is the number of times Striker will run in parallel to speed up the test execution. And we have configurations to test project and the configurations of mutants and excluded mutations or methods. It's nice because these configurations are versionized with the project. So any changes made will be recorded in Git history. but it's not required. If no one wants to do it, Striker will create something to be used in the execution itself. Okay, now I'm going to show a project only for demonstrations purposes on how we can use striker.net. Let me stop and share again. You can see my screen?
Yes, we can see your screen.
Okay. Nice. I'm in Visual Studio. The projects were developed using C# and .NET 7, the latest version of .NET. We have two projects. The first one contains the business rules, simulating an order item in a voucher class, in case we want to apply some discount or something similar. Trying to get closer to a real scenario involving an e-commerce application. And the second project contains the tests for our applications, where we have tests for each behavior, and also we have mocks to facilitate the creations of these tests. And we can go to the test explorer, where we have several tests to ensure the quality and the code coverage, and all tests are passing, which is an excellent sign that everything's okay, right? Okay. Let's see how the code coverage looks like for these tests. And for that, I'm going to run a command. And I will copy the command to save us some time. Here, it's generating and collecting some informations from the tests. Okay. We have 25 total tests, all passing. And now let's see the code coverage report. To do this, I will run another command to generate the report. Okay, now inside the test result and the generation, we have a report in HTML format. Let me open here. Okay, it shows in a very detailed way. We have 3 classes, 2 of them with 100% code coverage, and 1 with 91%, which is good. But let's take a look inside the voucher class. We can see the validate method. And there is a rule that validates if the voucher is valid or not. The voucher needs to be an expiration date greater than today, and needs to be active, and also needs to be a quantity greater than 0 to be valid. But we only have tests for the first scenario. Perfect. But let's take a look inside the voucher test class to see what happening. It's okay, the size of the code. we assume that yes. Okay. We have several tests to validate to a voucher. In this case, we have a test to create a valid voucher, so the result is true. We have a test to validate an expired voucher with actual or current dates. And we have a test to validate the voucher with yesterday date, an inactive voucher with, and we have a test with invalid quantity. So why the test coverage didn't catch these two scenarios? Well, a very common practice among developers is copy code from other places. And can be a problem or not. The point is that developer needs to know what is going on. And here is a copy from this test was made, where the voucher is created with yesterday date in all scenarios, but the other properties were correctly changed. In this case, the active is false and the quantity is invalid. Right, to fix them is quite simple. We just need to put the number 1, which means we use the actual date for create the voucher. And we can run the tests and generate another report to see everything is okay. Okay, let's run the generation reports again. The test still pass since the voucher still is invalid. Let's go, let's go, let's go. Okay. Now, let's run the code coverage report. Let's open the other folder and run the report generator. Okay, let's open and see the difference. Okay, perfect. Now we have 100% code coverage in all classes. All possible scenarios are covered by tests, which is wonderful, right? Okay, now let's finally run the mutation test to understand better. To do this, we just need run the command .NET. Sorry, it's the wrong folder. We need go to the test project folder. Here, the mutation test example.tests. And now run the .NET Striker. And the executions will begin. The Striker is running with 4 parallel processes. And while it's executing, let me show you the Striker config JSON, which is very similar to the one I showed in the presentation. We have the reporters, we have the required score for the tests, we have the concurrence and project informations, and some ignore mutations or methods in configuration section. Okay, going back to Striker, it identifies the test project and run the tests. And executions can be slow in some cases because the Striker will create several mutators for each test. Okay. The structure creates everything itself. It creates a folder called striker output with the date and time of the execution. Probably it's slow because I'm in the presentation, so it's always happening. Okay, we have some informations in the command report. Striker found 74 mutants, killed 55, and 4 survived, and 1 with timeout. But let's take a look inside the folder in the report, in the HTML report. And now it's very interesting. It showed that mutants were killed, were survived. Some of them were ignored. So we have a good number of mutants. But let's see inside of the models. If you consider that 80% is a good number, we have reached 93%, but with 100% code mutation score in 2 of the 3 classes. But the idea is take a look what's happening. Inside the voucher class, several mutants were created. In these validations, for example, 3 mutants were created. The original code is less than equal signing, and the striker changed it to greater, less than, and less than or equal sign. So with just one symbol, striker, 3 mutants were created. In the other examples, it's the same thing. The validations was false and striker changed to true. And in this scenario is similar to the first one. The validation is less than, and striker created 3 mutants. And the test is broken, which is an excellent sign. Perfect. And all mutants was killed. The next class is the order item. It's a class with few rules. And an interesting example in this scenario is here. Because an arithmetical symbol was changed. The original code is the multiplied value, and the striker replaced it to the division. And this class also achieved 100 mutation score. And now the last class is the order class, the most complex class with more rules, and striker found several mutants, many of which were killed. However, but unlike the other class, here we have some mutants that survive. Let's take a look what's happening. In this scenario, we the total value, the order total value is less than or equal to 0, and exceptions was generated. Whether it's throw an exception for a validation like this, it is also an interesting point but the point is that the code was implemented following these business rules. And let's take a look inside the order test to see what's happening. Here we also we just have a test to validate the sum of the items are higher discount of the total sum of items. What is missing in this case is a test when the discount are exactly the same value of the total order. I already have the tests to save us some time, but let me explain a little bit. The tests are very similar, but in this case, the discount is exactly the same case to discount of some of the items. In the other test, the discount is higher. So this is the difference. Since one is less, the other test is exactly the same value. Now let's run the test and run the .NET Striker again to see what is different. And I hope it will be faster in this time. Now let me see if we have any comments or questions. At least in this case, I guess the tests will execution fast. Or no. Okay, perfect. We can see in the command line generation and that the number of survive mutants has decreased. Let's take a look at the new report. Is the newest folder and open the mutation report. Open here and compare the difference. Okay, before the mutation score was 93, now is 95. And let's take a look. We just only have 3 mutants survival. and another one is dead. Nice. Okay, let's see the other survive mutants. Striker identify that I'm using the first or default function, where it returns the first element of a list, or a default value can be null. But when Striker changed to first function, in some scenarios the object can be null. And in that scenario, we need to validate the possibility as well. To validate this, we need to go to the order class and implement a small change in the code. We can create a method to validate if an existing item is belong to the order or not. Here's the method. We can generate a custom exception with a message saying that item doesn't belong to the order, and put this new method to guarantee this new behavior. So below the existing item was search, we can put this new validation and ensure this new behavior. Furthermore, we need to add new tests to add these new behaviors. Let's go back to the order test class and add these new tests. Like the other examples, I have already prepared this previously. But with a little explanation. Both tests are very similar. They create an order. This order contains some items, but a new item is being created. And this item is not a part of the original order. And in the test action, in the update and remove item, what we expected is exactly the exceptions, because the item is really doesn't belong to order. Let's run the tests, or simple run the .NET Striker again. Now we have 28 tests. The Visual Studio. If everything is okay, all tests will pass without any problems. But let's see what Striker.net tells for us. Now we have 28 tests, comparing to 26 and 25 in the first scenario. 80 mutants created, because I add new code and also new tests to guarantee to ensure these new behaviors.
Isaac,
Oi?
question. The mutant test can be a part of the cycle in pipeline
Yes,
stage.
yes, it's possible. It
How
is
you build the pipeline and put the mutant test?
uh,
What's the stage?
uh, in the homolog station or the yeah, well, let's I show it in the presentations. We have some considerations when we deal with mutant tests because the executions can be slow. So I recommend to put the striker.net in a separate pipeline and execution in the end of the week, because if you put in the default pipeline, it can be a time consuming. Or you can use striker.net with Git to identify the possible only the difference. So the mutant test will be executed in a pull request. So we can put these configurations in your pull request pipeline to execute the test.
Thanks, man.
Okay, let's see the new report. And the mutation score was increased, and we killed 2 more mutants, and only one left. Let's take a look. And in this case, where is it? Here. Is the exactly opposite of the previous one. I'm using the first function, and the striker changed it to first or default function. I had mentioned it before that it's possible to exclude some configurations, and for this specific mutant, we can use the options to exclude methods. So inside the striker config.json, inside the ignore method section, we can add the first method to ignore this method and run the test again, just to see what happened. The striker.net will ignore some methods, some methods and some tests, because I added this new section. And if everything is good, the final mutation score will be changed. We found 59 total mutants. Now we have some ignored because we added a method filter. Okay, 59 total mutants, all killed, bringing us to the magic number of 100% mutation score. Let me change the presentation for the presentation. With that, we reached in the end of the presentations, and I have a few small comments before we finish. It's not just about having 90% or 100% code coverage that means the tests are of good quality. We need to think about the behaviors, the rules that surround each of the test scenarios. Of course, always try to get the maximum post code coverage and mutation score as well, so that we have confidence to make refactorings and handle other scenarios of why we do tests. In the end, I think the goal of mutation testing is to have a new layer of validations and protections for what we do. And sometimes a small change in a sign can generate a very big issues in the future. And with these tests, we can find these problems as quickly as possible and save time and cost in the application. And I believe that that's what we are looking for. A nice and simple code for everyone to modify and obsessions with quality. And well, that's it. Please feel free to ask any questions or leave any comments. And all the code is available in this GitHub link for anyone who wants to take a closer look. And I want to thank you for your time and the TechWiki organizations.